Okay, so let's start with page 1 of our review sheet. Let's start with number 1. So as shown in the diagram below, triangle ABC is similar to triangle DEF. So something I like to do is I like to highlight the pieces that are going to be similar. So AB is similar to DE, right? Remember, it's always written in the same order in which it's similar. And then BC will be similar to EF. So BC is similar to EF, which means that our last pieces will be similar. AC will be similar to DF. Okay. Now we're given that we're looking for the length of AB. So we want to try to set up a proportion. And you know, coloring it makes it really, really helpful. So all you're going to do is let's set up our fractions. I'm going to have the yellow is proportional to the yellow the same way, and we're going to use the green. We don't want to use the red because we don't know anything about the red. So 7x and 7 and then 4 and x. We're going to cross multiply, so we get 7x squared is equal to 28. Divide by 7 on both sides. X squared is equal to 4. Take the square root of both sides. X is equal to 2. We're not done though, okay? Be really, really careful. Yeah, we got x is equal to 2, but that's not what we're looking for. We're looking for the length of AB. And AB was equal to 7x. So if AB is equal to 7x, then we must plug in 2 for x, and we get AB is going to equal to 14. All right, number 2. In the diagram below of right triangle ABC, CD is the altitude of hypotenuse AB. Is the altitude to hypotenuse AB. CB is equal to 6 and AD is equal to 5. What is the length of BD? So this is what we're looking for. This is our X. And X. So again, remember that strategy we talked about in class? Let's first identify which triangles we're going to use. I think we're definitely going to use this triangle because it has our X and it also has one known number, it has a 6. So I'm going to draw that back out. X, 6. Okay, and if we need to label it, C, B, D. And then the other triangle we're going to use is actually going to be the big triangle on the outside, right? So we can't use this triangle on the left because we have only one known side. We don't know this right side and we don't know the hypotenuse. So we're going to use the big triangle. So in our big triangle, again, let's label it. This is going to be 6. This entire side on the bottom, it's 5 plus x. Okay, remember that strategy we talked about in class? They both share 6 in common. So that ends up becoming our means. And then we'll have this is x and 5 plus x. Let's cross multiply. When we cross multiply, this becomes x times 5 plus x. If you're good, you can go ahead and do that in one step. I'm just going to write it out so I really know what's happening. And then 6 times 6 is 36. So let's distribute. This is 5x plus x squared equals to 36. We have a quadratic equation. Let me try to get everything, out of the way. Okay. So what we want to do is we want to set this equal to 0, right? Let me rewrite this. Minus 36 on both sides. And we end up getting 5x plus x squared minus 36 is equal to 0. Again, we want to put this in standard form. So I'm just going to rearrange it so it's in standard form. X squared plus 5x minus 36 is equal to 0. And over here, we're going to factor. When we factor, we want to look for two numbers that are going to multiply. Well, first of all, this is x and x. We want two numbers that will multiply to negative 36, but add up to positive 5. Okay, that ends up becoming plus 9 and minus 4. Remember from algebra, at this point, we're going to separate into two equations. X minus 4 is equal to 0. X minus 9 is equal to 0. On my left side, add 4 to both sides. You get x equals to 4 is a solution. And then on your right side, you're going to have minus 9 from both sides, and you get x equals negative 9 as a solution. Now, obviously, we can't have two different lengths, right? So let's go back and try to use some common sense and ask, ask ourselves, which one of these solutions would make sense and why? Negative 9 would not make sense, right? Because we are talking about the length of BD. BD was equal to x. X cannot be a negative number because lengths are never negative. It just doesn't make any sense. So the length of BD would be equal to 4. Okay, number 3. Triangle ABC shown below is a right triangle with altitude AD drawn to the hypotenuse BC. If BD is equal to 2, and DC is equal to 10, what is the length of AB? So this is what we're looking for. Again, let's identify the triangles we're going to work with. I think the first triangle pops out to me is triangle ABD. And again, I always like to redraw my triangles. ABD, I know from A to B is X, and then from B to D is 2. Now, the other triangle we're going to use is going to be our big triangle. Triangle ABC. So ABC, we have this is X and this is 12. So again, let's see. What they have repeating is the X's, so that becomes our means. And then the two other numbers, 2 and 12. Let's cross multiply. We get 2 times 12 is 24. X times X is X squared. We want to take the square root of both sides, so X is equal to the square root of 24. We never want to leave our answer like that. We want to simplify it as much as possible. The square root of 24 can be simplified to the square root of 4 times the square root of 6. And we know that the square root of 4 is 2, so that can come out of my radical. 6 is not a perfect square and also cannot be broken down any further, so that just stays inside our radical. All right, number 4. In the diagram below of right triangle ABC, altitude BD is drawn to hypotenuse AC. So altitude meaning these are right angles. If BD is equal to 4, AD is equal to X minus 6, and CD is equal to X, what is the length of CD? Okay, this looks a little bit challenging because we have so many X's, right? But again, let's identify the triangles we're going to use. I think we're definitely going to use triangle ABD. So let's redraw that one. Triangle ABD. And I mean it when I redraw these triangles. Like, please don't feel like you shouldn't do it. You know? And the other triangle we're going to use is this triangle on the right. Triangle DBC. I have X. And then this is 4. Take a look at what's repeating. So the 4s are repeating. Okay, and then we're going to write the other two, X minus 6 and X. Let's cross multiply. We get 4 times 4 is 16. This one really similar to number 2, right? So X times X minus 6. All right, let's distribute. X squared minus 6X is equal to 16. The next thing we want to do is to set this equation equal to 0 so that we can solve it. X squared minus 6X minus 16 is equal to 0. I'm just going to pull this part up here so that we have room. So right now, we're trying to factor it. I know my first terms are going to be X and X because X times X is X squared. My next two terms, I need two numbers that are going to multiply to negative 16 and add up to negative 6, right? So just if we forgot how to factor, really quick reminder. We want to multiply to our C value and add up to our B value. In this case, we end up getting negative 8 and positive 2. All right, just like problem 2, we're going to set each piece equal to 0. On my left side, we add 8 on both sides to solve. We get X equals to 8. On my right side, we minus 2 on both sides. We get X equals to negative 2. And we end up having to reject the negative 2. Okay, because Again, x was equal to the length of DC. I will not say DC is equal to -2. That literally does not make sense. You can't tell me something is -2 units long. Okay, that's the first page. All right, question number 8. In the diagram below, ABC, triangle ABC is similar to triangle DEC. Again, I'm going to do the same thing I did in question 6. AB, my first two letters, is proportional to DE because they're similar. The same way BC is proportional to EC. Sorry, I don't know what happened to me there. And then the last two sides will be similar to each other. So it's kind of like a mirror, right? All right, AC is equal to 12, so this is equal to 12. DC is equal to 7. DE is equal to 5. And the perimeter of triangle ABC is 30. What is the perimeter of triangle DEC? Ooh, that's a little bit challenging, isn't it? Well, I guess not. Okay. The first thing I'm going to do is try to find this green side because that's the only side that I can find information for right now. So I'm going to set up my ratio. Blue over blue is equal to green. So that's X over green. All right, let's cross multiply. I get 60 is equal to 7X. Divide both sides by 7. I'm just going to leave it as a fraction. X is equal to 60 over 7. Okay, if that's 60 over 7 and the perimeter of triangle ABC is 30, well, I can find out what BC is, right? Let's call this Y. So 12 plus 60 over 7 plus Y has to equal to 30. I'm just going to use my calculator to help me here. Well, let me do this first. 60 over 7 plus Y is equal to 18. And I'm going to minus 67 over 7 on both sides. Use my calculator. So we had 18 minus 60 over 7. I don't want that decimal. I'm going to convert it into a fraction. And we get 66 over 7. So this piece is 66 over 7. We're going to go ahead and use that to find our last piece, CE. Okay, so this time we're going to set up the ratio again. I'm going to set up my blues. So 12 over 7 is equal to 66 over 7 over, let's call this Z. All right, let's cross multiply. I get that this is 12Z is equal to 66 over 7 times 7 is just 66. And then we're going to divide by 12 on both sides. 66 divided by 12 gives us 5.5. So this is 5.5. Now if I want to find the perimeter of triangle DEC, we just add up all those sides. So 5 plus 7 plus 5.5 gives us 17.5. Now, there is an easier way to do this problem. And give me 1 second. Okay, so there is an easier way to do this problem. If the ratio of our sides has to be the same as the ratio of our perimeters. So let's go back and do it that way. Okay, so the way I just did was like the more long-winded out problem in case you don't remember this rule. But if you remember this rule, it makes the problem so much easier. The ratio of our sides has to be the same as the ratio of our perimeter. Same as ratio of sides. Okay, so if the ratio of our sides of the bigger triangle is 12 to 7, then I can set the ratio of my perimeter. Well, the perimeter of my bigger triangle is 30. I want the perimeter of my smaller triangle. Let's cross multiply. 12x is equal to 210. divide by 12 on both sides. So 210 divided by 12. We get x is equal to 17.5, which is the same exact thing we got before, right? Just made it so much easier if you can memorize this rule. So let's memorize it. And number 9. In the diagram of triangle ABC below, DE is parallel to AB. So these two sides are parallel. CD is equal to 4. CA is equal to 10. CE is equal to x plus 2. And EB is equal to 4x minus 7. And we're looking for CE. So we obviously have to solve for x first. So we do have two similar triangles here. We have this small triangle on top, and then we also have our larger triangle on the bottom. If it helps, let's redraw those two triangles. So triangle CDE, and we know they're similar because the lines are parallel, which means that they have corresponding angles that are congruent. Okay, so CD was 4. We don't know DE, but we know CE was x plus 2. And then my other triangle, the big triangle, CAB, this side is 10, and then this other side, we had to add these pieces together. So that's 5x minus 5. And now we can set our proportions. So 4 over x plus 2 is equal to 10 over 5x minus 5. And we're going to cross multiply. So 4 times 5x minus 5, that's where we have to distribute. 20x minus 20 is equal to the other side, 10x plus 20. Minus 10x from both sides. We get 10x minus 20 is equal to 20. Add 20 to both sides. Oh no, I'm running out of space. We get 10x is equal to 40. Divide by 10. X is equal to 4. But we are not done, right? Because we're not looking for x. We're looking for CE. And CE was equal to x plus 2. So we must plug in. CE is equal to 4 plus 2. CE is equal to 6. Awesome. So we're on to our third page of our review sheet. And let's take a look. Number 10 says determine if the following triangles are congruent or similar, and if so, by which method. So here are my two triangles. And we have that there's a parallel line between them. So what I do know is that they share this angle on top, right? So I already have one angle that is going to be congruent. Now, I don't know anything about the sides, so chances are I'm not going to be using the sides for any of these. I do know that we have parallel lines, and in parallel lines, we have corresponding angles. So already I know that triangle ADE will be similar to triangle ABC by angle similarity. Okay, let's look at number 11. Triangle ABC is similar to triangle DEF. There's no diagram drawn for us, which is a no-no, so let's draw our own. ABC and then DEF. So I know they're similar, so what I like to do is I like to write the letters in the same order. That way I don't confuse myself. I don't need to highlight anything. The lengths of side ABC are 5, 8, and 11. So it really doesn't matter which one because they're not asking us to find the sides. It says, what is the length of the shortest side of DEF if its perimeter is 60? So perimeter is equal to 60. Remember we said that the perimeter has the same ratio as the sides. We took that in the last, like 2 problems ago. So our shortest side is going to be 5. So I'm going to put that over the shortest side here. So 5 over x is equal to, well, the perimeter of this triangle, if I do 5 plus 11 is 16, plus 8 is 24. And then that has to be proportional to the perimeter of my other triangle. So I'm going to cross multiply. That's 24x is equal to 60 times 5 is 300. And then we divide by 24 on both sides. So 300 divided by 24, we get x is equal to 12.5. So the shortest side on triangle DEF will be 12.5. All right. Sorry guys. Next question. Number 12. In the diagram below of triangle ABC, they're telling us CDA is a line, CEB is a line, DE is parallel to AB, so I should draw that in. DE is equal to 4, AB is equal to 10, and CD is equal to x, and DA is equal to x plus 3. What is the value of x? Again, if you're, we've been doing similar triangles for so long, so some of you guys might not need to redraw the triangles, but I'm still going to do that for me. So CDE, that's one of my triangles. And the other triangle is going to be the big triangle on the outside. I know that the bottom is 10, but this entire side, I need to add up those two pieces to figure it out. That's going to be 2x plus 3. So this is 2x plus 3. So now I can set up my proportion. X over 2x plus 3 is equal to 4 over 10. And we cross multiply. 10x is equal to 8x plus 12. Should have done that over here so I have more room. Minus 8x from both sides. We get 2x is equal to 12. Divide by 2 on both sides. X is equal to 6. And that's what we're solving for. In the diagram below, AD is parallel to EG, so these two lines are parallel. Measure of angle BFC is 70, and that's drawn in for us. Measure of angle GFC is 39, also drawn in for us. Find the measure of angle FBC. So FBC, we are looking for this angle right here. Okay, so the first thing I'm going to do is I'm going to try to find the measure of this angle. Okay, my red angle. And what I know is that red angle, let's call it angle X. X plus 70 plus 39 has to equal to 180, right? Because they form a straight line. So 70 plus 39. So x plus 109 is equal to 180. Minus 109 from both sides. We get x is equal to 71. So this angle here is 71 degrees. And now that we have parallel lines, we're going to make our z to find our alternate interior angles. So I know that this angle that I'm looking for right here has to be the same as the angle that I just found. So measure of angle CBF must also equal to 71 degrees. Okay, question 14. The coordinates of endpoints A, B are A, -6, -5, and B, 4, 0. Point P is on AB. Determine and state the coordinates of point P such that AP to PB is 2 to 3. The use of the set of axes below is optional. So I'm going to do this algebraically. We want 5 pieces, right, because that's our ratio. So the first thing I'm going to do is take a look at my x-coordinates. My x-coordinates goes from -6 to 4, so to find the distance between them, we take the second x-coordinate and subtract the first coordinate. So 4 minus -6 is going to be 10. And then we have 5 pieces, so we divide by 5. Each of those pieces will be 2 units. All right, let's do our y now. Our y goes from -5 to 0, so again, we're going to do second y coordinate minus the first one. 0 minus -5 gives us +5. Again, we want 5 pieces, so divide by 5, and we get 1. All right, now we take the first ratio. We want 2 pieces, right? We don't want just 1 piece, so we're going to go back to our original coordinate, A, -6, -5, and we're going to do +2 twice on the x-axis because we want 2. And then we're going to do +1 twice on our y-coordinate. So -6 plus 2 plus 2 gives us -2. And then -5 plus 1 plus 1 gives us -3. Okay, awesome.